Hey everyone, Mr. Fransky here. Today we're going to be just doing some hyperbola practice problems. Hopefully this is helpful and you're able to graph some hyperbolas. So we're going to be able to graph conic hyperbolas given an equation and or information and vice versa. Alright, so vocabulary we've been talking about with hyperbolas. Hyperbola, obviously. Vertices, remember that's the places where the transverse axis meets the hyperbola, right? Asymptotes, those are the dotted line things, right? Conjugate axis is the imaginary one, right? That's how I remember it because it's conjugates like imaginary things. The transverse axis is the one that spans between the two vertices. The foci, remember, are hugged by the hyperbola. And completing the square, of course, going to be rearing its ugly head once again with hyperbolas. Alright, so here are the problems that I'm going to do. If you want to try them yourself, that's just fine. If you want to pause the video at any time and try it yourself, you can do that too. But let's jump in and give these a shot. So first we're just kind of graphing one. Remember, the way that we know if it's up and down or if it's side to side is just by looking at which part is positive. So in this case, the y is positive, so that means we're going to have a vertical hyperbola in this case. So now we're going to find our a and b. So a, the way that I do it, is always the horizontal value. So that's going to be the square root of this guy right under here. So a must be 2, and b, that means, is going to be 6. And it looks like our center is at 3, -1. All right. So let's get to graphing this thing. So our center is at 3, -1 right there. I'm going to put a dot there, even though it's not going to be a part of it, because that's where we're going to count everything from. Everything is always counted from the center. And so let's see here. A is 2, so I'm going to go right 2 and left 2. Okay, right 2 and left 2. So these are going to be the edges of my box to the left and to the right. B is 6, so I'm going to go up and down 6. 1, 2, 3, 4, 5, 6 right there. And down 1, 2, 3, 4, 5, 6 right there. So now we can create our box. Okay, so you just go left and right left and right A and up and down B, and we get those from the values underneath the Y and the X. And I'm going to draw in my asymptotes. The asymptote is going to go through the corner of the box and through the center. And here are my asymptotes. And now to graph the hyperbola, all we're going to do is go from the asymptotes. We're going to touch the top of the box here and go to the asymptote again. Very important that you approach those asymptotes. Don't make it too skinny, right? So we approach the asymptote, touch the edge of the box, and then approach the asymptote this way. Okay, so the asymptotes and the box are not a part of the hyperbola, right? The only parts of the hyperbola that really matter are the parts that you actually draw in here, but the box and the asymptotes really help us draw it. All right, so now let's find the foci. So remember, we have this relationship with hyperbolas that c squared is a squared plus b squared. A squared and b squared are given right here. So c squared in this case is going to be 36. Well, I should do it a and b, I suppose I'll put them where they belong. So it's 4 plus 36. So that means that c squared is equal to 40. So c is the square root of 40. Square root of 40 is something between 6 and 7. So from the center, remember, not from the vertices, I'm going to count from the center. We're going to go 1, 2, 3, 4, 5, 6. So the edge of the box is at 6, so it's just a little bit further, not much. Somewhere right like there and right like there. And the coordinates of those guys, then we're counting from the center. So the x-coordinate is definitely 3. Right? So the x-coordinate is 3. The y-coordinate is going to be -1 plus root 40. So -1 plus root 40, because all we did was count root 40, right, or just between 6 and 7, up and down. So 3 and then -1 minus root 40. So that's confusing to do. Just remember, we found root 40. We said, well, that's somewhere between 6 and 7. And, excuse me. And so what I did is I counted from -1 down root 40 and up root 40. So down root 40, that's this one, and up root 40, that's one right here. All right, let's try another one. So the hyperbola of foci 5, 2 and -5, 2 with conjugate axis length 8. Okay, so let's plot our foci first. So let's see, 1, 2, 3, 4, 5. They go up 1, 2. There's one focus. And -1, 2, 3, 4, 5, and up 2. There's our other focus. Okay, so these are foci. These are not vertices, right? These are the foci. So the hyperbola is going to be somewhere in here. So we learn a lot from this, right? One thing we learn that it's going to be a side to side. So the x is going to be positive. I'm just going to write that down so I don't forget it. So it's going to be a side to side. And then I also learned the center. right? The center is going to be smack dab in the middle of those foci. So because we're at positive 5 and negative 5, it looks like we're on the y-axis with our center. Center, I think, is going to be right there at 0, 2. 0, 2. We also learn our C value. Our C value, we gotta go right 5 and left 5 to get to C. So C is 5. And let's see, the conjugate axis length is 8. So the foci are going to lie on the transverse axis, which is the one that's between the vertices. So our conjugate axis must be a vertical. So that means if the whole length is 8, I'm going to go up 4 and down 4. 1, 2, 3, 4. There we go. And down 1, 2, 3, 4. That's going to mean my B value is 4, because that's the vertical, right? So those are the top and bottom edges of my box. I don't know where the right and left edges are. I want to find them though. So C squared is A squared plus B squared. So in this case, that's 25 is equal to A squared plus 4 squared is 16. So if I subtract 16 from both sides, 25 minus 16 is 9 is equal to A squared. So that means A is 3. I got a frog in my throat, I'm sorry. Alright, so A is 3, so I'm going to go left and right 3. 1, 2, 3 right there. And 1, 2, 3 right there. And that defines my box. Asymptotes go through the corners and through the center. And then we can create our hyperbola. So it's going to touch the edge of the box. That's where the vertex is going to happen. There we go. Same thing over here. So we don't go through the foci at all. It just goes through the vertex on the edge of the box. And then it approaches those asymptotes on the top and bottom. So let's see if we can come up with an equation for the hyperbola. So the x part we said is going to come first. So I wrote that here. The x coordinate of the focus, or the center, is 0, so we just have x squared over a squared, which we got right here is 9. And then minus, right, because it's hyperbola. So now we have the y part. So it's going to be y minus 2 over the b squared, so that's 16, equals 1. There's our equation. We've got our foci. They gave them to us, so we don't have to find those. Not too bad. Transverse axis length is 6 altogether. Conjugate axis, they told us, has a length of 8. There we go. 2 down, 2 to go. Completing the square, my favorite. So, first of all, we can know this is hyperbola because we see we have this subtraction in front of the y squared, and we have a positive x squared. If they were both positive, it would be an ellipse, and if only one of them was squared, it would be a parabola, right? So let's see here. Let's gather the x's. So we're going to have 4x squared plus 24x, then minus 25y squared, plus 100y, minus 164 equals 0. So let's get all the x's grouped, and they are, and so we're going to pull out a 4. So I pull out a 4, I'm left with x squared plus 6x. Going to leave a blank there, because that's where we'll complete the square. Now what am I pulling out from the y's? I'm pulling out a negative 25. And I'm left with y squared minus 4y. Leave a blank there, and then we'll move the 164 to the other side. Now let's see if we can use a different color here, maybe, to complete the square so we can see what this step happens. So if I divide 6 by 2 and square it, so 6 over 2 is 3, squared is plus 9 there. What did I really add? 4 times 9 is 36, so I'm going to add 36 to the other side. Now here, negative 4 divided by 2 is negative 2, squared is a positive 4. What did I really do? Well, I subtracted 100. Subtracted 100. Okay. So, let's see what happens here. We have 4, we'll go back to green maybe. So we have 4 times x plus 3 squared, right? That's the factoring of that. Minus 25 times y looks like minus 2 squared. It's a 5, I promise. That's equal to, let's see, 164 plus 36 is 200. Minus 100 is 100. So now we want that to be 1. So I'm going to divide both sides by 100. Like that. So 4 over 100 is 1 over 25. So I have x plus 3 squared over 25 minus y minus 2 squared. 25 hundredths is 1/4 is equal to 1. There's my equation. Now, we're not asked to graph this, but why not? Let's give it a shot. So center is at negative 3, 2. There's our center. A is 5, because that's under the x. I'm going to go right 1, 2, 3, 4, 5, right there. Left 1, 2, 3, 4, 5, right there. B is 2, so go up and down 2. Up 2, down 2. So it looks like the edge of our bottom edge of our box is right on the x-axis. Here's our box. Oop, There we go. Okay, corners through the center, corners through the center. Now, are we left, right, or up, down? Looks like the X part is positive, so we're left, right. So it's going to be snuck right in here. Should touch the edge of that box. That's my fault. Over here as well. And then if we want to find the foci, let's see. C squared would be 29. A squared plus B squared. So C is root 29. So we go left and right a little more than 5. 1, 2, 3, 4. So 5 is the edge of the box, so focus there. Focus there. The coordinates of those guys would be, let's see, negative 1, 2, 3 plus root 29. And the y coordinate is 2. And negative 3 minus root 29, comma 2. Or foci. Awesome. Cool. Okay, I think we got one more. Hyperbola of vertices negative 1, 3, and 5, 3 with asymptotes that have slope plus and minus 4/3. Okay, so the slope thing, this has to do with the fact that when you draw your box, right, when you draw your box, here's the center. The distance from the center to the top is B. The distance from the center to the edge is A. So if you know the slope of the asymptote, well, the slope of the asymptote is rise over run, but rise is B and run is A. So the slope is always going to be B over A. But the tricky thing here is that this could be a reduced fraction. So this could be an 8 and a 6. This could be, what, a 12 and a 9. They have lots of options for A and B, so they must tell us something else. Well, they told us the vertices, so we're going to be able to find either A or B, and then we're going to be able to use that information to figure out what the other letter is. So let's see what's going on here. Let's draw a graph. So negative 1, 3, and positive 5, 3. Okay, those are my vertices. So it looks like we're going to have a sideways hyperbola here. I don't know where my asymptotes are, so maybe I shouldn't have drawn it quite yet, but I just kind of want to get a picture of it. So the transverse axis then has a length of 1, 2, 3, 4, 5, 6. Okay, so the transverse axis has a length of 6, which means that our A value, because it's horizontal, is equal to 3. So if A is 3 and 4/3 is B over A, then B must also be 4. Okay, because this is B over A, and we found out that A is 3. It's not like 6 or 9 or anything weird. It's just 3, so that means B is 4. Okay, so we can go up and down 4. Here's down 4 from 1, 2, 3. There's the center. And then we go up 1, 2, 3, 4. There, so there's our box. Pretty close to a square. You can have a square, right? It's not like an ellipse where it would create a circle. If it's a square, it just means that your asymptotes have a slope of 1 or negative 1, right? Okay, so approaching those, maybe made it a little bit too narrow, but that's not too bad. There we go. All right. So there's our hyperbola, and now we got an equation for this thing. So center I didn't label yet, but let's see, it's a 2, 3. So the center is at 2, 3. I should write center instead of C, because C could be confusing. 2, 3. So we're going to have x comes first because it's a horizontal, side to side, Lady Gaga style hyperbola here. So we have x minus 2 squared over a squared, so that's going to be 9, minus y minus 3 squared over b squared, which is 16, equal to 1. There you go. Foci, let's see, c squared is going to be a squared plus b squared, so that's 9 plus 16 is 25. Yeah, that's a nice number. So c is plus and minus 5. So I go right 1, 2, 3, 4, 5 right there. Left 1, 2, 3, 4, 5 right there. So let's see, 2 plus 5 is 7. So 7, 3. And 2 minus 5 is negative 3, 3. Those are our foci. Nice. All right, I think that's all I've got for you today. So I love you guys. That's why I'm here. Hopefully you learned something about hyperbolas, and good luck on the test.